Hello, good evening, everyone. Am I properly audible? Hello, everyone. Am I audible? Yes or no? Hello, hello, hello.
Yes, sir. You are audible.
Okay, so there are 7 students.
Yes, sir.
They have joined. Okay, fine. So, good evening to all. And yes, today it is a lecture in which I am going to introduce you the fluid mechanics and hydraulics for gate. I hope that everybody is comfortable with the word fluid mechanics and hydraulics, and everybody knows that for what purpose they are giving the gate examination. So I am not going to talk about the gate examination. As far as the fluid mechanics and hydraulics is concerned, you all are familiar with these two topics because in many of the universities at UG level, there are two courses in fluid mechanics, and maybe in some of the universities, this particular subject or course might be knowing as a hydraulics. There is only one difference in hydraulics and fluid mechanics. In fluid mechanics, we are talking about the fluid. Fluid may be a liquid or it may be a gas. It may be anything. It may be a kerosene. It may be the water. It may be the mercury. It may be the glycerine. The, that is a fluid. Whereas whenever we are talking about the hydraulics, mainly we are dealing with the water. So as far as uh, this is concerned, this comes under the section 4 of the water resources engineering. Actually, it is not correct to say that the fluid mechanics and hydraulics, they are the water resources engineering. They are basically a fundamental course, right? But they are brought in the UPSC examination and the GATE examination under the category water resources engineering. So as far as this section 4 is concerned, there are 4 parts of the section 4. First is the fluid mechanics, and you can well see that in the fluid mechanics we have to discuss the properties of fluid, fluid statics, continuity equation, momentum equation, and energy equation, and how they are being used in the fluid flow problems or application to the fluid mechanics. Thereafter, the potential flow. This may be a new topic because in most of the universities, the potential flow, it is not the part of the fluid mechanics. So this is maybe the new topic which we have to discuss. Thereafter, the laminar and turbulent flow, mostly that is in the advanced fluid mechanics, flow in pipe networks, and thereafter the concept of boundary layer and its growth. So the concept of the boundary layer, that is a very unique concept, and it is a very important topic to understand so that you can find out the forces for the case in which the water or liquids, they are flowing on a boundary. So how the boundary layer is developed and what is the significance of the boundary layer and how the force is calculated, can be calculated by the concept of the boundary layer, that we are going to discuss, and the concept of lift and drag. One thing that which I could see in the syllabus, forces on immersed bodies, that is given in the hydraulics. Actually, it is not the topic of the hydraulics, it is also the topic of the fluid mechanics. Because whenever we are talking that a plane is just moving in the air, or the kite is just flying there in the air, that is the case of the forces on the immersed bodies. So it will be the part of the fluid mechanics. Thereafter, the flow measurement in the channel and pipes, you all have done it. Dimensional analysis and hydraulic similitude, open channel hydraulics, energy depth relations, and all these. These are the topics which you might have covered. Here I have, now the another topic is the hydrology and irrigation. So I think that some other faculty, they will take care of these two topics. Now these are some of the books which these are the textbooks available in the market, or during your graduation you might have purchased. So keep all those books with you. Although if not, you can purchase any one of the book, either R.K. Bansal or R.K. Rajput and Modi and said that is more than enough. Or Jain, A.K. Jain, that is more than enough to understand the basic concepts. Now, why I say always that fluid mechanics is a subject, or it is a course which is affecting your interest in the 10 courses. Okay. In the case if you are not having you are having the improper knowledge of the fluid mechanics, certainly you are going to be a loser in the following 10 courses, which are shown over here. It is important to understand the advanced fluid mechanics. The concept of the hydrology and irrigation engineering, they can be well understood only and only if you are having a good knowledge of the fluid mechanics and hydraulics. Certainly, you cannot go for the design of hydraulic structures if you don't have in-depth knowledge of the fluid mechanics and hydraulics. Water power engineering, it partially requires the knowledge of the fluid mechanics and hydraulics. Water supply engineering and wastewater engineering, certainly you will become the master of the hydraulic design only and only if you are familiar with the fluid mechanics and hydraulics as far as these two courses are concerned. Thereafter, we can go open channel, groundwater flow, air pollution, and geotechnical engineering. In geotechnical engineering, whenever we talk about the flow of water through the porous media, certainly the knowledge of the fluid mechanics, that is R and hydraulics, is important. Open channel flow, groundwater, and air pollution, these are the electives in many of the universities. Now, if we come to the part A, properties of fluid. So everywhere in every university, this particular course is there, fluid mechanics and hydraulics. So I think you should be familiar with all these topics: properties of fluid, fluid statics, continuity, momentum, and energy equations and their applications, flow in pipes and pipe networks, concept of the boundary layer and its growth, and concept of the lift and drag forces on immersed bodies. So these are the topics. Here I have just marked red. As far as these two topics are concerned, you may not be familiar with this, right? So you have to start, as far as this is concerned, you have to start from fundamental, okay? Right? These two topics, potential flow and laminar and turbulent flow. And here concept of the boundary layer and its growth, and concept of the lift and drag and force, drag and lift forces on immersed bodies. These may also be the new topic for the students of some of the universities, because in many of the universities, one particular topic, these topics, they are excluded from the UG course. Now, another one is the hydraulics. I have already shared with you that what is the difference between the hydraulics and the hydraulics and fluid mechanics. Here, flow measurement through pipes, right? Venturi meter, orifice meter, pitot tube, right? So that is the topic. You must have done it. Flow measurement in open channel, notches and wear. Thereafter, in open channel hydraulics, in every university, this particular subject course, this particular topic may be there either in the fluid mechanics or in advanced fluid mechanics. That is the energy depth relationship, specific energy, critical flow, hydraulic jump, and uniform flow. But the gradually varied flow and water surface profile, that may not be the part and parcel at UG level, unless or until you are not opting open channel hydraulics as a elective, professional elective. So here, this topic, gradually varied flow and water surface profile, and hydraulic simplitude, these may be the new topics in the second part for you. So certainly you have to start from the basics or fundamental. Now, just whenever I am talking to my students about the this fluid mechanics and hydraulics, that what is the prerequisite for the fluid mechanics and hydraulics? Prerequisite, I think you understand the meaning of it. The meaning of the prerequisite is that what knowledge you should have before starting this particular course. Okay. So even not only for the fluid mechanics, I always say to my students that the basics are the prerequisite for being a successful civil engineer. That is only the physics, and in physics, the general properties of matter, that is the chapter number 1 or topic number 1 or module number 1 of 10th class, 11th class and 12th class. Thereafter, basic algebra of 11th and 12th class and basic geometry and trigonometry of 11th and 12th class, and whatever the calculus, differential and integral calculus you are studying at first year of the engineering, that is more than enough for you to crack any examination. There is no rocket science or no just mathematics of second year or third year engineering level or the physics of the BSc level or MSc level that is required for you to understand the basic concepts of the civil engineering. This is more than enough. Only the thing is what you have to do, that you have to just again go to the supposed to have the this books of the 11th and 12th class, just sort it out where the chapter general properties of matter is there, or in the case if you are having the old book books or notes which you have prepared or which you have read at the time of the 11th and 12th class, okay, keep it in front of you and start from the basic. Just revise what you have studied, try to understand, that means comprehend the things, and now you are ready for the better understanding of or fundamental understanding of the fluid mechanics and hydraulics. You see, here you cannot mug the things because everything, every basic knowledge you have to have for solving the problems. In the case, if we talk about the Bloom's taxonomy, because you are now graduate, so you must know this particular word because of the accreditation and all these process, accreditation and recognition process. All the students, they are told that what are the different learning level. That means the pedagogy or basics of the pedagogy, all the students, they are aware of it. So the first one is the memory. That means you have to memorize the things. Some definitions are there, something, whatever is given in the books, especially suppose that if in the case of, if I say that what is the Bernoulli's theorem, right? What is the Archimedes principle? So I think that you cannot change the language of the Archimedes principle or Archimedes statement because it is given by him. The same thing with the Bernoulli's theorem, right? So you should remember it. But at the same next level is that you have to understand it, comprehend it. Third is that you have to apply it. Fourth one is that you have to analyze it. And fifth one is that you have to evaluate it. And sixth one is you have to go for the creation of some new thing. So we are not talking about the creation. I'm not talking about the evaluation, right? And even at this level, where I'm going to, or whatever is the content of the syllabus is there, right? You are not supposed even to analyze it. You should know that how to apply it. So for application, it is essential that you should understand or you should comprehend the things. Now here, if we just only, I am going to rush these slides, only you can see the figures and you can just try to understand it, right? Now these are the three configurations of the intermolecular bonds are shown. So well, you can understand the first one is of solid, second one is of the liquid, and third one is of the gas. Liquid and gas both are known as the fluid. Now, well, you can see these are some photographs. Directly it can be taken from the internet, and here you can see the jet of water, it is coming and it is the water is flowing. Here this is a thermal diagram. The second figure is a thermal diagram which is showing you that how the flow is taking place and hydraulic jump is taking place. So it is also a flow. Flow is changing from subcritical to supercritical state. And here you can see in the third figure that how the smoke, colored smoke, that it is flowing in the atmosphere or within the contained place, right? So this is all that how the fluid is flowing, and this is what the liquid or gas phases are there, and liquid phases are there, and gas phases are there. So this is known as a fluid. Actually, what does it mean by fluid? Fluid, it is a substance which can flow. Now, you may ask that I may ask you, if you are answering like this, that the fluid is a substance which can flow. Then the next question comes in, that what is flow? What is flow? Now, the flow is a little bit complicated. Just to explain the flow, you cannot say simply the movement of the fluid from one place to another place, that is a flow. Structurally, you have to define that what is the meaning of flow, that which I am going to just do. I explain you at the end of or at the mid of this particular discussion. Now here, you all are aware of these terminologies and these notations. We are using for force PRF, and for mass we are using M. Mass, it is expressed in kilogram, and PRF, they are expressed in Newton. These are the units. Force is equal to mass into acceleration. So, well, this is the dimension of the acceleration. Dimension, how we write the dimension? We write in the terms of the three fundamental units. What is that? Mass, length, and time. Right? So, to mass, we say M. For length, we say L. And for the time, we just have the notation of, we use the notation of T. So, well, here you can see, you all are must be familiar with this. This type of the exercise you might have done at your 11th or 12th level. So, this is the way that how we can find out what is the dimension of the acceleration due to gravity. It is the acceleration, meter per second square. So, for meter, we have to use the notation L, and for the second square, we have to use the notation T. So, T raised to power 2. Because it is in denominator, so it will be L into T raised to power minus 2. So, like that, we can find out the dimension of the different. Now, here, mass density, you all are familiar with this. Rho is equal to M into V, mass per unit volume. In the same way, you can just simply find out that what will be the dimension of the mass density. Mass density, it is also known as a specific mass, and mostly in every text, it is just expressed as a rho. Weight density or a specific weight, it is expressed as weight per unit volume, and it is its notation in most of the text, that is gamma. So, the same notation we are going to use. So, here in case of the mass density, in case of the weight density, you can just find out the dimension of each, right? In case of the mass density, it will be M L raised to power minus 3 T raised to power 0. T raised to power 0 means it is 1. There is no T terms. But you have to express, because there should be some, because these three are the fundamental units. So here we have to incorporate it, but because it is not coming into picture in that particular dimension, so we are writing T raised to power 0. So like this, we can find out the dimension of each and every property of the fluid. Now, specific gravity, you all are aware, it is a comparison of the gamma or rho of the fluid with the reference fluid. Never say that the gamma or rho of the fluid to gamma or rho of water. No, it is gamma or rho of a reference fluid. Reference fluid in case of the liquid is pure water at 4 degrees Celsius, and in case of the gases, it is the air or the inert gas at the STP. STP means standard temperature and pressure. For the case of the fluid, certainly liquid, it is certainly gamma. This reference fluid is a pure water, and its value of gamma is 9810 Newton per meter cube, or 9.810 kilonewton per meter cube. And for water, rho of water, that means mass density of water, it is 1000 kg per meter cube. See that in numerator as well as in denominator, we are having the same quantity, and hence it is G is a unitless or dimensionless. What is the dimension? What would be the dimension of the G? The dimension of the G would be M raised to power 0, L raised to power 0, T raised to power 0, because it is dimensionless. So, it is 1, 1, 1. Now, there are few more terms, okay, that is specific volume. The specific volume is volume per unit weight. Remember, it is also volume per unit mass, but in fluid mechanics, we use volume per unit weight, whereas in thermodynamics, we use it as a volume per unit mass. Now, you can say, sir, if the specific volume, it is volume per unit weight and volume per unit mass, so how to recognize it, that which one is correct? So certainly, you have to see that what is the unit, because whenever you are expressing anything and you are not writing any unit, it is it is a half information. It is not a correct information. So whenever it is in meter cube per Newton, you can understand that it is a specific volume for to be used in the fluid mechanics, where V upon W, that is the specific volume, and if the unit is meter cube per kg, then it is the specific volume to be used in the thermodynamics, and the unit is meter cube per kg. So in that way, and it is volume per unit mass. So in that way, you can just find it out that where we are going to use it. Now this cohesion and adhesion, this is the basic fundamental of the general properties of matter, which you might have studied at your 11th and 12th class. Cohesion. Now you all know about the Newton's law, that force is directly proportional to the product of masses of the two force in between the two particles, that is proportional to the product of the mass and inversely proportional to the square of the distance between them. So already you have just studied it. I think it has started from the 8th class and onwards, those who have studied the science. So here, intermolecular force between the two particles of the same material, right, that is known as a cohesion. And the intermolecular force between the two dissimilar substances, two dissimilar particles having the different properties, that is known as a adhesion. So understanding of cohesion and adhesion, it is very important from you, because unless or until you do not understand it, you cannot go ahead with the capillary rise, right? Capillary rise and surface tension. Now surface tension, I think you must have done the surface tension at your 12th level, right? Now you can see the two molecules, one is at the surface and another molecule is at somewhere in the mid of the liquid, which is filled in a container. So the particle which is at the surface and the particle which is at some distance below the surface. Now you can see this particle which I have just picked, you can see that it is being pulled by the forces which is having the magnitude F. That means all the sides, which type of the particles are there? All the side is having the particle of the same material. All the sides are having the particles of the same material. So it is being pulled in the downward side by the force of cohesion, in the upward side by the force of cohesion, in the diagonal side by the force of cohesion, and in the lower diagonal side by the force of cohesion, in the left, from the left and right, both the side by the force of cohesion. Now the force of cohesion with which it is being pulled from all the sides have the same magnitude. So this is in the state of a stable equilibrium, because from the same magnitude of the force it is being pulled on all the sides. Whereas this is not happening at the particle which is at the top. At the top, from the left side, you can see force of cohesion is there. In the right side, you can see the force of cohesion is there. And similarly, in the bottom, in the downward side, the force of cohesion is there, but in the upward side, the force of adhesion is there. So here, this particle which is at the surface, it is subjected to the either downward force or upward force, depending upon that what is the relative magnitude of the force of adhesion with respect to force of cohesion. So if it is being pulled downward side, that is known as a surface tension. If it is being pulled upward side, that is also known as, that means every particle which is at the top, that is either being pulled downward side or it is being pulled upward side. So it is in tension. The forces in the upward and downward side, they are not balanced. I say the same thing is on the diagonal side. Only on the horizontally, on the horizontal side, that means from the left to right, this is balanced. But from all other side, it is not in the equilibrium state. So every particle, it is in tension either on the downward side or on the upward side. So now here, these are few examples of the surface tension. I am not going in detail of it, right? Spherical shape of the raindrop, that is the one of the example, rise of sap in tree, because these are the small questions which you may get in the GATE examination, right? Fundamental questions, capillary rise and capillary siphoning. That means all the roots of the plant, they are just pulling the water from the pores of the porous media, dust particle on the water surface, breakup of the liquid jet, rolling of the water droplet on the leaves of the plant. So some of these are the example of the surface tension, right? Thereafter, sigma, right? Now this is a force which which causes a tension that acts parallel to the surface. So I think that this is the derivation you might have done at your UG level, that in the case if the droplet of the liquid is there, so what is the excess pressure inside? Suppose that inside the pressure is P1 and outside the atmospheric pressure is P2. So P1 minus P2, that is the pressure difference inside the droplet and outside of the droplet. So how it is related with the diameter? So delta P is equal to 4 sigma upon D, right? So here sigma is the surface tension force and its dimension is unit is Newton per meter. So here this type of the derivation you need, if in the case if you understand it, if you are getting such questions, you can immediately derive it. Actually here what is happening, the surface tension force around the surface of the droplet, that is balancing the excess pressure inside the droplet. So excess pressure inside the droplet, that is acting on the entire area. Here we had cut the area, right? So it is a circle. So well, you can find out that here in this area, all the forces are acting, right? So this is pi by 4 d square into delta P, and it is balanced by the sigma into pi d, because this sigma force, sigma means surface tension, that is acting on the periphery of the droplet. Both are balancing each other, and simply you are getting delta P is equal to 4 sigma upon d. So in the case if you are able to understand it, immediately you can derive the formula. Neither you have to remember for a droplet, it is 4 sigma upon d. Then for the soap bubble, it is 8 sigma upon d. And then for the excess pressure inside the liquid jet, it is 2 sigma upon d. So in the case if you are having a good memory, then it is well and good. But even then you have to understand that how this 4 sigma upon d, 8 sigma upon d for the soap bubble and 2 sigma upon d for the liquid jet, you are getting as a delta P. Delta P means excess pressure inside and outside the bubble or jet or the droplet. Now capillary reaction, you might have derived it already, this formula, right? H is equal to 4 sigma cos theta divided by gamma d. Now here actually there is a concept of that, suppose that you are having a bottle of water in the bottle, and just due to your negligence, the water, it is just falling on your table. What it is going to what is going to happen? This is going to wet the surface, right? But at the same time, if you are having the mercury in the this a bowl, and just if you are just due to negligence, that mercury, it is just falling on the table, what is going to happen? Mercury is not going to surface, not going to wet the surface of table. So wetting of the surface of the table, and in the case of mercury, all the mercury droplets, they are just rolling down on the surface of the table, right? Why it is so? Again, the same cohesion and adhesion is coming into picture. In case of the mercury, the force of cohesion in between the mercury and mercury particle, that is more as compared to the mercury and the particles of the material of your table. So what is happening? Because mercury to mercury, the force of cohesion is more, So mercury is rolling down on your table and it is not hitting the surface. But it is not happening in case of water. In case of water, what is happening? The force of cohesion between the molecules of water and force of adhesion in between the molecules of water and the material of the table. They are, so force of adhesion is more and force of cohesion is less. So that is the reason that why water is going to wet the surface. So this is a simple concept, but you have to understand because many questions you can get and in the examination, which may be either theory based or maybe numerical based, but unless or until the fundamentals are not clear, if the same question is twisted, you will not be able to give the proper answer. In the case if you are not properly comprehending the concept of the cohesion and adhesion. So now you all are aware of this also. This is the property which you might have done at your 12th level also and in the engineering also, compressibility or the bulk modulus of elasticity. Now here even you can see that there is a piston, there is a container and in container a piston is there. Initially some gas is filled, right? And V is the volume. V is the volume of the gas in the container. Now you are pressing the piston with the force P. What is happening? Right? What is happening? That piston is coming down. Now the mass of the gas is same, but the gas are whatever the fluid is there, that is compressed, right? It is compressed by the volume dV. So dV upon V, that is the volumetric strain, and the increase in pressure, that will be delta P. Delta P or dP. dP means initially the pressure was 0, or let us say initially the pressure was P1 and now the higher pressure is P2. So P2 minus P1, that is the change in pressure. Change in pressure divided by the volumetric strain, that gives you the bulk modulus of elasticity. It is something same related to the Young's modulus of elasticity, what you might have studied for the solids. So K, it is the bulk modulus of elasticity, dP upon dV upon V. Now, many of you may think in this way that why the minus sign is incorporated in the denominator. dV upon V with the minus sign and dP, it is there with the plus sign. So why minus sign is there? So the answer is whenever either you are taking x-axis and y-axis. In x-axis you are taking, let us say, the pressure, and in y-axis you are taking the volume. So actually what is happening? When pressure is increasing, volume is decreasing. Pressure is increasing, volume is decreasing. So whenever we are considering the scale, right, we should take the second one in y-axis as a negative scale because that is decreasing and pressure is increasing. So just to compensate it, mathematically we have written the minus dV upon V. So here what will be the unit of the bulk modulus of elasticity? Right, bulk modulus of elasticity, here it will have the unit of Newton per meter square because whatever is the unit of pressure, because in the denominator what we are having? We are having the volumetric strain. Volumetric strain is change in volume divided by the original volume. So in the numerator and denominator, both the places, the volume is there. So it is a dimensionless. So dP K is equal to dP. dP means as far as the unit calculations are there, K will have the same unit, whatever the unit of the dP, that is the Newton per meter square. Now there is another concept of the compressibility, which is equal to 1 upon K, right? Now, this is a also topic which you might have done at your 12th level, also at the engineering level. Those who are, if you are in the mechanical engineering, then certainly the concept of the vapor pressure is very important, particularly those who are dealing with the pipelines, flow through pipes, right? So the topic of vapor pressure is there. This is a little bit, just you have to understand that physically what is happening just at the surface of the liquid, right? There are vapors of the surface of the liquid above it. So you have to study it in detail. You have to understand only then and then you can answer related to this particular topic properly, right? Thereafter, we have the this topic of which is known as a pitting, right? Pitting, that means erosion of material. Erosion of material on from the surface where the fluid is flowing, right? And the pressure inside the conduit, that is well below the vapor pressure. So if the pressure inside the conduit is below the vapor pressure, what happens? All the gases and air which is dissolved in the liquid, they liberate out in the form of the balloons of air, right? And at the area or in the zone where the pressure is more, all these balloons, they get burst, right? So millions of balloons are formed at the zone where the pressure is less, and they are getting burst at the area where the pressure is more, in the zone where the pressure is more. So well, you can see this is the good diagram just to understand that. You see where the pressure is less, the balloons are formed, and where the pressure is more, balloons are burst. And where the balloons are burst, the pitting takes place. This phenomena is known as cavitation, right? Now, Hitesh, Mr. Hitesh, Mr. Hitesh. Okay, so I think either everybody is listening or nobody is listening to me. 1, 2, 3, 4, 5, and 6. Now the question comes in. Just initially I asked one question that what is flow? So, or what is fluid? So fluid is a substance which can flow. Now the answer of this question, that what is flow, that is a little bit difficult to, or it is not that way easy to answer that what is the flow. Now you see what happens in the case of the liquid. In case of the liquid or gases, there is a flow, or whenever the flow is taking place, the velocity of all the layers, different layers, that is different. The layer which is in immediate contact of the solid boundary, it is having the velocity equal to the velocity of the solid boundary, and as we are going across the flow, the different layers, they are having the different velocities, and as we are going away from the solid boundary, the velocity increases. Now here in case of, let us consider the case of a solid. It is a solid block, and this solid block, it is subjected to shear force. I think that you all are aware of the meaning of the shear force. Shear force, that means it is a force which is applied parallel to the surface. So that is a shear force. And if the force is perpendicular to the surface, then it is known as a direct stress or direct force. So shear means it is just trying to haul it in two parts in the direction of the flow, right? Two or many parts. So force acting in the direction of flow. But initially I am just talking about the solid. You can see this block. This block, it is fixed at the bottom, and at the top we are applying certain force. Let us say it is the shear force, and the magnitude of the shear force is Fp. So what will be the shear stress? If the area in which this shear force is acting, that is AO, then the shear stress tau, that is going to be Fp upon AO. Now here, because of this shear force, what is happening? The top surface of the block, that is deforming by the distance delta x. It is deforming by the distance delta x. So certainly, because the shear force, it is acting parallel to the surface, this delta x you are going to get parallel to the surface, and across the direction of the shear force, the dimension is h, then delta x, that is a change in length, the direction in which the force is applied, and the h, it is the dimension across the flow, across the surface. So delta x upon h, that is known as the shear strain. Now, the same thing can be expressed with the help of this practical example. What is that practical example? You are having, let us say, two sheets. One is in the bottom and another is the top, and in between there is you are having the erasers. rubber, cold rubber ज्याला म्हणतात. So you are having that eraser and you are placing the eraser in between these two plates and you are gluing it, right? आप कुछ फेविकोल वगैरह लगा के आप इसको जोड़ देते हैं. So that is a rubber. You are just gluing it in between the two plates. Now the lower plate, you are just screwing it on the table so that lower plate cannot be moved. But upper plate, you can apply the force. Whenever you are applying the force Fp on the upper plate, what will happen? The rubber will get deformed. The rubber is deformed. Why it is deformed? Because of the application of force Fp. So now here the shear stress which this deformed rubber is experiencing, that will be Fp upon AO. What is AO? AO is the contact area on which this shear force is acting. So here AO is the area of the rubber at the top. So Fp upon AO, that is the shear stress. Now, once you are removing this shear force, what will happen? The deformation of the rubber will not be there. Rubber will come to its original position. It will be a rectangular block. So why this rubber is coming to its original position? Because, and why it is deformed? Because it is having a shear strength. Under the influence of the shear strength, it is coming to its original position, right? And it is going to be applicable for any block. It may be a rubber, it may be a steel, it may be anything, okay? But in the case, if the Fp which you are applying, that it is beyond a certain limit, what will happen? 100% it will not come to its original state, right? Some deformation will be there, okay? The plate, the object, it will be deformed, but the object will be deformed. It will not come to its original original state because it is permanently deformed, even after removal of Fp. But this deformation will not continue. Once you are removing Fp, it has deformed, but it will not come to its original position because the force it is applied beyond it was beyond a certain limit, right? I think you try to remember the Hooke's law which you have studied. Now, the position of the liquid or gases. Here, let us talk about the liquid, because if I am talking about the gases, you may be a little bit confused. So, in the case, if in between these two plates, a liquid is there, and initially what will happen if the liquid is not flowing? The bottom plate and top plate both will be parallel to each other. But if liquid is there, some thick liquid is there, and you are applying the force Fp, what will happen? The top plate will start moving. Top plate will start moving. It will continue. Let us assume that the liquid is also coming continuously in between the plates. So now the top plates will start moving. So this is what? Actually, this is the flow of the liquid. Why? Because the liquid does not possess, or the shear strength of the liquid is too less as compared to the solid. So whenever you are applying the force Fp, that is a shear force, there is a process of continuous deformation till the force Fp is in action. And the liquid will start moving. So this continuous movement of the liquid under the action of the shear force, this is known as a flow. So this is a technical definition of the flow. The fluid, when subjected to shear force, it experiences a continuous strain. There is a continuous deformation. It experiences a continuous deformation. And this process of continuous deformation is known as flow. Because the fluid possesses a very small amount of the shear strength. It is negligible as compared to the solid. So this process of continuous deformation when subjected to shear force is known as the flow. So this way you have to understand the difference between the solids and liquid. Okay. Now here, the another important thing in which you have to understand or which you have to comprehend in case of the fluid mechanics, that is a no slip condition. I think that this is the last topic which I am going to discuss with you today. No slip condition, because without no slip condition, you cannot solve any problem of fluid mechanics. And it is that the layer which is in immediate contact of the solid boundary will have the velocity equal to the solid boundary. Now, when you can see here, from my left to right, the fluid is flowing and it is approaching to the solid surface, which is a plate. Okay. Now, when the fluid is not in contact with the solid plate, what is there? All the layers, they are having the same velocity. Layer number 1, 2, 3, 4, 5, right? V1, V2, V3, V4, and V5, all are having the same velocity, right? Now, once this mass of the fluid, it is approaching to the solid plate, right? The velocity of the layer, which is in immediate contact of the solid boundary, will have the zero velocity. So V1 will become 0. But the layer number 2 will have the velocity greater than V1. Layer number 3 will have the velocity greater than V2. Layer number 4 greater than V4, V3, and so on and so forth. So this will be the velocity triangle. This will be the velocity triangle. Now, each and every layer is having a different velocity. So, the momentum of each and every layer will be different. So, in between these two layers, they are going to experience a force, right? So, this is the low slip condition, and this is the basis for the understanding the Newton's law of viscosity. Tau is equal to mu into du upon dy, right? So, this is all about the properties of the fluid. You must be familiar, because the questions related to this particular topic may also be asked, right? That what is the meaning of the elastic fluids? What is the elastic solids, and what is the meaning of the ideal fluid? So, in a x-axis and y-axis, starting from the x-axis and up to the y-axis, in the counterclockwise direction, the different types of the fluids and solids are there, right? Here, when you can see all the blue color line, they are not following the Newton's law of viscosity. So they are known as they are representing the non-Newtonian fluids. And all the red lines, they are representing, that means in between the x and y axis, they are representing the Newtonian fluid. Even the ideal plastic, that is also a Newtonian fluid after a certain yielding stress. So this is a very important graph which you have to understand, because you cannot mug this entire graph to answer in any competitive examination. You have to understand the meaning of it, right? So this is all what I wanted to discuss. And as I told you that many other topics are there. Each and every topic, whether it is in the fluid mechanics or whether it is in hydraulics, you have to have the proper understanding of the fundamentals. Now, the basics of the fluid mechanics, the prerequisite that which you have to have a better understanding of the course, that is the Newton's second law. It is a law. Then next is the law of conservation of mass, law of conservation of energy, Pascal's law, then hydrostatic law of pressure variation, Archimedes principles, Newton's law of viscosity, and cohesion and adhesion forces, about which we have already discussed, and concept of the vapor pressures. So if you know all these things, certainly you can have the in-depth knowledge of the fluid mechanics and hydraulics, and you will be capable of answering any questions, whether it is asked to you the straight way or it is twisted. For solving the numerical problems which are asked in the GATE examination, you should have the proper understanding of these topics of the physics along with the properties, and then certainly you will be able to answer properly, and just you will reach to the correct answer, whether it is a objective type questions or whether it is a subjective questions. So thank you. I think that it is more than enough. I think I have taken around 1 hour. So I stop sharing this presentation. If you are having any questions from your side, you may please ask.
Thank you, sir. I think we have only one participant. Siddhant is there and Prachi is there.
How many have joined?
We had 7 students were there, but I think they have left 10-15 minutes before.
Okay, fine.
Yeah. So
Thank you then.
thank you so much, sir. It was very nice session with you.
Only for the last student who is still over here.